Okay, so we've already looked at the derivative of sine x and cos x measured in radians. Now we need to look at the derivative of tan x measured in radians. Okay, now to do this again I'm going to use autographs. So I'm going to go to autograph and open up a 2D page. We get this. We'll just get rid of this thing on the bottom here, because we don't need that. So we'll just right click, get rid of show key. Again we'll set the axis, so click on the axis. Again we're going to do from 0 to pi, 2 pi. Okay, so pi, remember, is pi, and then we'll leave y as it is, and we'll change the x to pi divided by 4, and the pips to pi divided by 4, and we'll leave the y's to, as they are, as 1, and we'll press OK, and then we get our axis. Okay, I'm just going to put the asymptotes. We know for tan x we get asymptotes here, here and here, so we'll put those in first. So let's do those. X is equal to pi by 2, okay, and x is equal to 3 pi by 2. Okay, we'll just click on those. We'll make those both blue, so we'll change the colour of that one to blue, and we'll make them dotted as well because they're asymptotes. So we'll do that by going to Object, Edit Draw Options, and changing the dash star to that. In that case, press OK, sorry. And in that case, Object and Edit Draw Options, and we'll change that to dash like that as well. Okay, so there we've got our asymptotes. Okay, so just we'll put in now y is equal to tan x, so we'll get the graph of y is equal to tan x. So I'm just going to change that to being red. Okay, and I'm going to label it. Oh, sorry, I need to select it before I label it. So select it and then label it. Get rid of the equation 3 bit. Let's just convert it to static text. And we'll press OK. And we get that. Okay, so there's our graph. Okay, so if I now want to do the derivative of that, now before that I'm just going to go to View and Keyboard. I want the keyboard so I can label it OK. So View and Keyboard, which is this one here. Okay, we'll come with that later. Just put that into one corner. Now I'm going to select the tangent graph, so it goes black, and select gradient. Okay, so I'm just going to put first derivative, press OK, and lo and behold I get the graph of it there. Okay, what is the graph of this? Okay, so the graph of this is actually 1 over cos squared x. So we're just going to label that, and I'll show you that in a minute that that's true. So just going to click on that graph. Okay, go to text box and convert it to static text, and we're just going to put here that, sorry, just get rid of this bit, the first derivative y prime is going to be equal to 1 divided by cos, and we need this is where we need this, so we'll go to text squared, the little squared sign you can find up here, just press it once only though, x, press OK, and then we've got the graph that we want. Okay, and then if I label that, I'll just put the arrow to it. So this green looking graph here is the derivative, and it's 1 over cos squared x. Just to show you that that's true, if I go to the graphing not selecting anything and put in y is equal to 1 divided by brackets cos x squared, which, okay, you'll see it overlays the green graph. Okay, so the derivative of tan x is 1 over cos squared x. So there's a graph of what I've just done, a screenshot of what I've just done, and the conclusion is if y is equal to tan x, dy by dx will be equal to 1 over cos squared x. or d dx of tan x is equal to 1 over cos squared x. Okay, these need to just be remembered. I've just shown you graphically this is not a formal proof.